grounding electrode and an electrode conductor are not required for this installation. According to the National Electrical Code, a grounding electrode is required for a building or structure if any of the following conditions are met. Firstly, there is a service disconnect that is grounded to the grounding electrode conductor. Secondly, there is an equipment grounding conductor that is connected to the grounding electrode conductor. And thirdly, there is a path to ground for fault current that does not include the grounding electrode conductor. In this case, none of these conditions are met. The service disconnect is not grounded to the grounding electrode conductor. There is no equipment grounding conductor that is connected to the grounding electrode conductor, and there is no path to ground for fault current that does not include the grounding electrode conductor. Therefore, a grounding electrode and an electrode conductor are not required for this installation. Let's break down each of these conditions in more detail to ensure a clear understanding of why grounding electrode is not necessary in this specific scenario. Firstly, consider the service disconnect. In typical electrical installations, the service disconnect is the main point where electrical power enters a building or structure. It is designed to isolate the entire electrical system from the utility power supply for maintenance or emergency purposes. The NEC often mandates that the service disconnect be grounded to a grounding electrode conductor. This grounding provides a low impedance path for fault currents to return to the source, which helps to trip over current protective devices like circuit breakers or fuses quickly, minimizing the risk of electrical shock or fire. However, in the described fiberglass vault installation, the service disconnect is not grounded to a grounding electrode conductor. This implies that the vault's electrical system is fed from a separately derived system, or a different grounding arrangement is in place that doesn't rely on a direct connection to a grounding electrode at the vault itself. Because the service disconnect does not meet this requirement, the first condition for needing a grounding electrode is not met. Secondly, let's examine the role of the equipment grounding conductor. Equipment grounding conductors are crucial for ensuring that all metallic parts of electrical equipment, such as motor housings, panel enclosures, and conduit, are at the same electrical potential as the ground. This minimizes the risk of electric shock if someone touches a metallic part that has become energized due to a fault. Typically, equipment grounding conductors are connected to the grounding electrode conductor, which in turn is connected to a grounding electrode. This connection provides a path for fault current to flow back to the source, again facilitating the rapid tripping of overcurrent protective devices. However, in this specific vault installation, the description states that there is no equipment grounding conductor connected to the grounding electrode conductor. Instead, the equipment grounding is achieved through other means, such as the metallic conduit system or dedicated equipment grounding wires that run with the circuit conductors. This alternative grounding arrangement, while compliant with the NEC, does not necessitate a separate grounding electrode at the vault because the equipment grounding path does not rely on it. Therefore, the second condition for needing a grounding electrode is also not met. Thirdly, consider the path to ground for fault current. In an electrical system, a fault current is an unintended flow of current that occurs when there is a short circuit or insulation failure. A properly designed grounding system provides a low impedance path for fault current to flow back to the source, which helps to quickly clear the fault and prevent dangerous voltage buildup on equipment enclosures. The NEC requires that this fault current path include the grounding electrode conductor in many cases. This ensures that the grounding electrode plays a role in the fault clearing process. However, in the described fiberglass vault installation, there is no path to ground for fault current that includes the grounding electrode conductor. This means that the fault current path is established through other means, such as the equipment grounding conductors and the metallic conduit system. Because the fault current path does not rely on a connection to a grounding electrode, the third condition for needing a grounding electrode is also not met. It's important to emphasize that while a grounding electrode is not required in this specific scenario, the electrical installation must still comply with all other applicable requirements of the NEC. This includes ensuring that all equipment is properly grounded, that overcurrent protective devices are correctly sized and installed, and that all wiring is done in accordance with the code. The absence of a grounding electrode does not imply that the installation is unsafe or non-compliant. It simply means that the specific conditions outlined in the NEC that would necessitate a grounding electrode are not present in this particular case. In summary, a grounding electrode and electrode conductor are not required for the fiberglass vault installation because none of the three conditions specified in the NEC are met. These conditions relate to the grounding of the service disconnect, the connection of the equipment grounding conductor to the grounding electrode conductor, and the path to ground for fault current. Since none of these conditions are met, the absence of a grounding electrode is permissible under the NEC. It is important to consult with a qualified electrical professional to ensure that any electrical installation complies with all applicable codes and standards. This professional can assess the specific conditions of the installation and determine whether a grounding electrode is required. Furthermore, they can ensure that all other aspects of the electrical system are properly designed and installed to provide a safe and reliable electrical supply. Keep in mind that electrical codes and standards can vary depending on the jurisdiction, so it's always best to consult with local authorities to ensure compliance with all applicable regulations.